is repeated at regular intervals of time or periods. To illustrate how the Fourier series may be used to represent complex waveforms, let's first apply a single sine wave to a square wave with period t. To construct a sine wave with the same period, we draw a vector and rotate it one revolution per period. The vertical projection of the vector tip oscillates up and down once for each revolution of the vector. When the projection moves to the right at a uniform rate, it draws a sine wave. To estimate how well the sine wave represents the square wave, we can superimpose one on the other. The approximation is only fair. The error is about 19%. Next, we tried the same fundamental, or first harmonic, and the third harmonic. If we stop the action momentarily and add the vectors, the sum produces a waveform. Which obviously is a better representation of the square wave than was the first harmonic alone. How much better is shown by the superposition test. The error is about 1/2 as large as before. When three harmonics, the first, the third, and the fifth, are added, the resultant waveform is an even better representation. If we again superimpose, we find the error now down to about 7%.